All right, let's enjoy example number 3 on ellipses. And once again, this will correspond to assignment number 24. And so here's example 3. We've got the equation, we've got the boxes, the graph paper. Please fill them in just like I'm doing on the examples. So one of the things that's different about this, see, the standard form is fraction plus fraction equals 1. I guess I would focus on the 1 here. That 36 isn't 1, is it? Okay, so we've got to do a little bit of manipulation to the equation before we can identify all the various parts. So how do you change a 36 into a 1? Well, you could subtract 35. Yeah, I would acknowledge that would work. But another possibility would be to divide by 36. And I hope if you put some thought into it, you would agree that if we divide this by 36, that'll create a 1, which is just the way it has to be for it to be an ellipse. It's got to equal 1, standard form. But not only will dividing by 36 create a 1, but it will also create some fractions on the other side of the equation. In my opinion, this is kind of one of the rare occasions where we actually want fractions in an equation. Look at the standard form, fraction plus fraction equals 1 at the top of the slide there. So, for several reasons, dividing by 36 is going to be a good deal. It'll make a 1 and it'll create fractions over here. All right, so we have 4x squared over 36 plus 9y squared over 36. And then you'll notice that we can reduce these fractions because 4 and 36 make a 9 on the bottom, and 9 over 36 makes a 4 on the bottom. Reduce the fractions, and there you go. And I think we're ready to roll with this one. So let's identify the center point first. What would x have to be for that to equal 0? 0. What would y have to be for that to equal 0? 0. Much like the previous one, example 2, watch these in order, okay? They build on each other, but the origin 0, 0 would be our center point. Those are the numbers that are being subtracted from x and y. Implied. That's x minus 0 squared. That's y minus 0 squared. Vertices, co-vertices. All right, a squared, in this case, is 9. And if you square root both sides of that, you find out that a would equal plus or minus 3. And I want to remind you in my generic picture that a is horizontal, left and right. The denominator of the x fraction will lead you to the left and right. X is left and right. So we're going to go 3 units to the right. So from here we go 1, 2, 3, boom. Let's label it. Wouldn't that be x is 3, y is 0? That's on the far right edge of the ellipse, if you will. All right, and then 3 units to the left would be the ordered pair negative 3, 0. There you go. So those are extreme points. Those are on the edge, the right and left edge of the ellipse. What about up and down? B. Look at the formula. B squared is the denominator of the y fraction. Y is up and down. B is up and down. So b squared for this question would equal 4. And if we square root both sides of that to solve for b, b would equal plus or minus 2, wouldn't it? Plus or minus 2. Up 2 plus, down 2 minus. From the center point, up to, what ordered pair is that? 0, 2. Yeah, 0, 2. Let's go to the center and go down 2 units. What's that ordered pair? 0, negative 2. Draw the ellipse. Cool. All right, now vertices. Major axis. Given the fact that 3 is a bigger number than 2, wasn't the horizontal shift, the distance we traveled horizontally, bigger than the vertical? Therefore, the vertices are these 2 points. 3, well, okay, negative 3, 0, and 3, 0. And then, of course, the co-vertices, the minor axis, the shorter distance traveled from the center would lead to co-vertices, which in this example are 0, 2, and 0, negative 2. There you go. Vertices, done dirt cheap. Co-vertices. All right, been there. Everybody having a good time? Yeah. Me too. Except I miss you guys a lot.